I'm Will, and this is the third of 4 videos I've made summarizing the projects I've worked on here at Princeton. This video focuses on the dynamic resistance probe, or DRP, which I've used to measure propellant condensation, and which has applications to plume divergence measurements and measurements of plasma reattachment to spacecraft. This might be one of the simplest diagnostics ever created. I put a piece of steel tape on a stick. That's really about it. The idea for this diagnostic came out of the joy that is working with lithium propellant, which coats everything in the tank in a conductive, hazardous mess. I was wondering if I could somehow turn that weakness into an advantage. One of the characteristics of lithium is that it is about 10 times as conductive as steel, which means that as lithium coats a piece of steel tape, the resistance of that tape will change as a function of the lithium thickness. By measuring that resistance as a function of time and with a little bit of math, you can figure out how quickly the lithium is being deposited. There's a standard way to make this measurement using something called a quartz crystal microbalance, or QCM, which involves a vibrating piece of crystal, but this was used previously with the LILFA, and the error was 20% of the measurement. I tried my tape on a stick at the same location, and the error was only 6%, or less than a third of that found using QCM. And it was super cheap and easy to make. I also made more sophisticated versions, which are curved such that they represent a fixed radius in the plume of the thruster. By positioning the probes at a number of radii, you can get an idea of the mass distribution in the plume, or the plume divergence. This probe most easily measures the total accumulated propellant on a surface, and for that reason is well suited to measurements upstream of the thruster, where plasma may follow magnetic field lines back to the spacecraft. You can imagine that coating a spacecraft with lithium might be a problem. However, our facilities are not large enough to allow for such a measurement, and so we have not investigated that topic. This concludes the third video. The fourth and final video will focus on 2 different projects: the design and implementation of a liquid metal feed system with no moving parts, known as a J-X-B pump, and the design, construction, and testing of the argon Lorentz force accelerator, or ALPHA.